Students, here we are again, trying to explain to you how hydrates are formed. As we said yesterday, hydrates are binary compounds that are composed by a metal with hydrogen or a non-metal with hydrogen. In the case of the metals, it can be any metal that is on the left side of the periodic table combined with hydrogen, and they exchange the oxidation number. In the case of the non-metals, we have to distinguish two different groups. The compounds that are formed with the metals from the group 13, 14 and 15 from the periodic table, which are in this order, first the non-metal and then the hydrogen, and the non-metals that are taking part in the groups 16 and 17, they are written this way, first the hydrogen and then the non-metal. So in the case of the non-metals, when they combine with hydrogen, we have to distinguish if they are part of the group 13, 14 and 15. In this case, the non-metal is written first, in the first position, and then the hydrogen. And if those metals are taking part in groups 16 and 17, first the hydrogen is written and then the non-metal. How they are formed? So, in the case of the hydrides that are formed with metal, let's take as an example the nickel. Nickel with oxidation number 2. Nickel with oxidation number 2, it combines with hydrogen, they exchange the valences, the oxidation numbers. Nickel gives the number 2 to the hydrogen, and then the hydrogen gives the number 2 to the nickel, so it's going to stay this way. The systematic name of this is going to be nickel dihydrate, and in this case, as it has 2 oxidation numbers, it's compulsory to write in the stock nomenclature the valence or the oxidation number between brackets. So it's going to be nickel 2 in Roman letters, hydrate. In the case of the oxidation number 3, it's going to be nickel H3, because they exchange valences this way. It's going to be nickel 3 hydrate in the case of the systematic nomenclature, and this is going to be the stock nomenclature. And this one is going to be nickel 3 between brackets hydrate. Okay? If the metal is platinum, for example, it has oxidation number 2 and 4, is going to be platinum, hydrogen, they exchange valences, this is going to be 2, and the name is going to be platinum dihydrate, and platinum 2 hydrate. In the case of platinum 4, it's going to be exactly the same, but with this oxidation number 4. It's going to be platinum 4. Yes, 4, as we said, yes. Tetra hydrate, and then platinum 4 hydrate. Mercury is going to be the same with those 2 oxidation numbers. Let's mention now, for example, calcium, which has oxidation number 2 and is unique. It has just one oxidation number, this number 2. It's going to be CaH2, they exchange the oxidation numbers, and here we are going to mention calcium dihydrate. But in the case of stock nomenclature, it's going to be calcium hydrate. We don't write any number here, no, because it's a unique oxidation number. Okay, so we follow this rule in all the cases. When the oxidation number is unique, we don't write the valence between brackets in the case of stock nomenclature. Let's see what happens with metals. Here we have the example of boron, which is on group 14, and group 13, sorry, silicon, which is in group 14, and phosphorus, which is in group 3. Okay, so they are going to be formed, as we said, first the non-metal and then the hydrogen. Yes, so it's boron the first, hydrogen, they exchange the valences. Boron gives valence 3 to the hydrogen, and this is going to be the formula finally. The name is going to be boron trihydrate, but it has a special name which is borane. It has a special name which is borane. In the case of the silicon with hydrogen, they exchange the valences again. Yes. And we have silicon and H4. Yes. And the name of it is going to be silicon tetrahydrate. And the special name is going to be silane. Okay. And in the case of the phosphorus exchange the valence with it. Hydrogen has valence 1 always, so it's going to be phosphorus trihydrate, and the special name is going to be phosphane. Okay, so non-metals, the ones we have mentioned, group 13 is valence -3. Boron and hydrogen, they exchange the valence, a special name borane. Silicon, they exchange valences, silicon for hydrogens, silane, the special name. In the case of the phosphorus, a special name here, phosphine, as we said. We continue with non-metals from group 16 and 17. Okay, so we are going to mention first the example of the sulfur. Okay, so in the case of the sulfur, fluorine and chlorine, as they are from those groups, we have to remember that first is the hydrogen written and then the non-metal. So they exchange the valences. Hydrogen has valence 1, sulfur here has valence 2, is going to be this way. Okay, in the case of fluorine, is 1 and 1 both, is going to be this way. In the case of chlorine, 2 is 1 and 1, both have 1 and 1, chlorine 1 and hydrogen 1, they exchange and they remain this way. So in this case, so they have the capacity of being dissolved in water and they create acids. This is why they have the special name of hydrochloric acid, this one, hydrochloric acid. Okay, so this is going to be hydrofluoric acid. Okay, and this one, which is made of sulfur, hydrosulfuric acid. Okay, so this is the way they have to be named after these rules we have been learning in this lesson. So if you have any difficulties after trying doing your exercises, please don't hesitate reaching me and ask me any questions you have. Remember that we have the current at the beginning of the classroom. You can pose to me any type of questions. Good luck. See you soon. Bye-bye.